is Nur Aina binti Muhammad. The metric number is F180072. So I will explain about the theory and the backgrounds of the falling heat test. The falling heat test is a short sample connected to a standpipe which provides both the heat of water and the means of measuring the quantity of water flowing through the sample. Several standpipes of different diameters are normally available from which can be selected the diameter most suitable for the type of the material being tested. This objective of the falling heat test is to determine permeability of soil of intermediate and low permeability. To describe the general accepted practice to determine the coefficient of permeability of silts and clays. To identify the relationship between permeability and pore size of the fine-grained soils. And next is to measure the coefficient of permeability of silts and clays. Tests of clays, much higher hydraulic gradients than are normally used with sands can be applied, and are often necessary to induce any measurable flow. The cohesion of clays provide resistance to failure by piping at gradients of up to several hundred, even under quite low confining of surcharge pressures. Dispersive clays, however, are very susceptible to erosion at much lower gradient. The falling head principle can be applied to an undisturbed sample in a sampling tube and to a sample in an odometer consolidation cell. The equation used in determining the permeability of the fine-grained soil is given.
Hi, my name is Muhammad Ikhwan Shafa bin Mat Samsudin, AF180139. I will talk about the equipment of this project. This is the constructed constant heat permeability cells. To set up these separators, we need a few equipments. First is fitted with loading piston. Second is flow tube connections. Next is vernier caliper, ruler, stopwatch, and lastly, measuring cylinder.
My name is Muhammad Shakiri bin Rahmat. Okay, my metric number is AF 180164. First, open the valve at the top of the cylinder. Rule of thumb: valve is open when aligned with the tube, like this. Okay, second, open the valve at the bottom of the cylinder. Make sure the valve is aligned with the tap and the nozzle is submerged in the water bath. Okay, third, prepare your timer before starting the actual test. To start the test, open the valve at the lower end of the standpipe, which is right tube.
My name is Nurul Batrisha binti Abdul Rahman.
Once all the valves are open, water will start to drop immediately in the right tube. Timer should start immediately after opening the valve. Record the time for every 30 centimeters drop of water. Then, for datum, obtain the height between the zero position of the standpipe scale and the water exit nozzle at the bottom of the sample.
My name is Muhammad Amrul Idham Muhammad Kamal. Okay, for the outcomes, the coefficient of permeability for our soil sample is first K1 equal to 8.51 times 10 power of minus 7. K2 equal to 4.39 times 10 power of minus 7. Then K3 equal to 3.30 times 10 power of minus 7, and K4 equal to 2.79 times 10 power of minus 7. And for the average of the coefficient of permeability is equal to 4.7475 times 10 power of minus 7 meter per second. So based off the average, the sample is classified as silt or silt clay. From here, we can conclude that the seed clay comprised mainly of intermediate sized particles are fertile, fairly well drained, and hold more moisture than sandy soils, but are easily compacted. Silt as a soil separate consists of mineral soil particles that are 0.002 to 0.05 mm in diameter. Then, silt has a relatively limited surface area and little chemical activity. Lastly, soils high in silt may compact under heavy traffic, and this affects the movement of air and water in the soil.
I'm Ishad Ime bin Yahya. My metric number is CF180090. I will explain about the conclusion of this project. As the result, we can able to describe the general accepted practice to determine the coefficient of permeability of silts and clay. Identify the relationship between permeability and pore size of the fine-grained soil and measure the coefficient of permeability of silt and clay. Permeability can be defined as the ability of a porous medium to allow the flow of a fluid through it, typically expressed as the coefficient of hydraulic conductivity. A porous medium is a material granular or fibrous containing void space. In this particular project, the medium studied was super safe, design asphalt mixture, and the fluid used was distilled water at the room temperature. This test was initially investigated for two primary reasons. First, the calculate permeability value for sample test using this setup, as well as the permeameter assembly and process itself is easily checked for consistency. Secondly, the validity of Darcy's law for the test executed in the laboratory can be evaluated. It was initially assumed for the test that Darcy's law is valid and that the hydraulic conductivity is essentially unaffected by hydraulic gradient.
Hello, Assalamualaikum. My name is Nurul Farhana Mikti Rahmat. My metric number is AF180049. Today, I would like to present about the guideline used for this project. So, the research showed that this falling head permeability test is a common laboratory testing method used to determine the permeability of fine-grained soil with the intermediate and low permeability such as silts and clay. This testing method can be applied to an undisturbed sample. The title is Falling Head Permeability Test Lab Report, publisher script, writer is Shahrul Rain, and year published 2014. Falling head permeability test involve flow of water through a relatively short soil sample connected to a standpipe which provide the water head and also measuring the volume of water passing through the sample. The diameter of the standpipe depends on the permeability of the test soil. The test can be carried out in a falling head permeability cell or in oedometer cell. Before starting the flow measurement, the soil sample is saturated and the standpipe are filled with the air water to a given level. The test can be started by allowing the water to flow through the sample until the water in the standpipe reach a given lower limit. The time required for the water in the standpipe to drop from the upper to the lower is recorded. Often the standpipe is refilled and the test is repeated for a couple of times. The recorded time should be the same of each test within and allow variation of 10%. Hit 1982, otherwise the test is failed. The title is Manual of Soil Laboratory Testing, Volume 2, published by HKH and writer by Pentach Press, year published 1982.